if we take a look at this first one, it says, what is the range of y equals x squared minus 5 when the domain is the set of values -1, 0, and 3.5. And essentially what this is asking us for is to make a t-chart. Remember, the range is just the y values, and the domain is just the x values. So if we have the x values of -1, 0, and 3.5, we just have to see the y values that go with that. So I'm just going to plug these in. Y equals the x value of -1. When I plug this in, that's going to give me -1 squared in parentheses is 1 minus 5. It gives me a y value of -4. So the first value for my range is going to be a -4. And now I plug the 0 in. So I have a domain value and x value of 0. I want to see what the range with the y value that goes with it is. So that's y equals, that's going to be 0 minus 5, which is a -5. So again, I'm getting y values here. So that's my next range value, my next y value. And then the last y value, again, I got to plug this in. That's y equals 3.5 squared minus 5. And again, I just plug this in, so I square this. So y equals, that's going to be a 12.25. And then minus the 5 is going to give me a 7.25. So that's my last range value. But then the last thing I should do, since I have my range values, is technically I should have these written in order. So really I should write it as -5, -4, and then the 7.25. And that's my range. Again, it's just the y values that go with those x values. For the next one, it says to find the sixth term in the sequence. And really, we've got the first four. We just have to decide what's the pattern that's happening here. So in other words, how do I get from the 8 to the -2? How do I get from the -2 to the -12? How do I get from the -12 to the -22? And either we're going to be adding something each time or subtracting something each time, or multiplying or dividing. And with this one, it looks like what we're doing is we're subtracting 10 each time. In other words, 8 minus 10 gives me a -2. -2 minus 10 gives me the -12. Minus 10 gives me the -22. So minus 10, the next term, would be a -32. And then minus 10 for the next term would give me a -42. And that is my sixth term. I already had 4 of them. So the answer here is the -42. And that's it. So it's just identifying the pattern. For this one, it asks if 6(3) is a solution for the inequality, and it asks us to explain why or why not. So what we have to do here, really this is an x and a y value. All we have to do is plug in our x and a y value and see if the inequality holds true. See if one side is greater than or equal to the other side. So I'm going to plug these in. So I'm going to take this off to the side. It's going to be 2. The y value is the 3 minus 9, and we want to see if that's greater than or equal to the 4 times x, which is the 6 minus 8. And now we just have to simplify each side of this. I'll start with this side. 2 times 3 is a 6. So I've got 6 minus 9. I'm following order of operations. That's going to give me a -3. Then I do the same thing over here. Got my greater than or equal to symbol. I start inside parentheses. 6 minus 8 is a -2. 4 times a -2 is a -8. And now I have to ask myself the question, is this true? Is -3 greater than or equal to -8? And the answer is yes, that is true. That does check out. So that means that 6(3) is a solution. So yes, this is a solution. And the reason it's yes is because it holds true when we plug it into the inequality. So it holds true, it checks out. Okay. Taking a look at number 18, number 18 says to tell whether the following system has one solution, infinitely many solutions, or no solution. And really what we're going to do here, this is a system of equations. So I'm just going to solve this system of equations. And I'm going to start by getting rid of fractions. Okay? I don't like dealing with fractions, and the easiest way to do that is to multiply through by the common denominator. So if I look at these denominators here, I've got a 4 and a 9. The common denominator between 4 and 9 is going to be a 36. So what I'm going to do is I'm going to multiply each side of this equation by 36. Multiply this side by 36, and I multiply this side by 36. And what that's going to do, that's going to eliminate the fractions. Here I'm going to distribute that 36. And when I do that, I'm going to rewrite this equation over here. Essentially, I'll get 36x over 4, but 36 divided by 4 is a 9, so that'll give me a 9x, plus 36 times y is a 36y, but divided by 9 is going to leave me with a 4y. And then over here, the 27 times the 36 is going to give me a 972. And now I'm going to do the same thing with the other equation. I'm going to multiply through by the common denominator. Here the common denominator is 6, so I'm going to multiply each side by 6 and rewrite this. So now over here again, if I distribute the 6, because I have to distribute this, that's going to give me an 18x over 2, which is going to be a 9x. Then that's going to give me a 12y over 3, which is a 6x. Or sorry, that is a 12y over 3, which is a 4y. So that's a 4y. And then the 19 times the 6, which is going to give me a 114. And now to solve this, because these look so similar to one another, I'm going to solve by elimination, which means I can add or subtract the two equations from one another. So here I'm going to subtract the two equations. And when I do that, remember that's like adding the opposite. So when I add straight down, a 9x plus a negative 9x is 0. 4y plus a negative 4y is also a 0. And then over here, the 972 plus the negative 114, that's going to give me an 858. And so what I'm left with is 0 equals 858, which is not a true statement. 0 does not equal that. And since we ended up with no variables left in this equation, and the statement I got is not true, it means that there's no solution. So there's no solution for this one. If I end up with a statement that is true, it's infinitely many solutions. And if I only had one solution, then I'd find an x and a y value, an ordered pair that works for each equation. So this one's going to be no solution, because I end up with a false statement. The next one says Mike withdrew $32 from his bank account at an ATM machine. The transaction slip said his balance was $289.48. What was his previous balance? And keep in mind the directions here ask us to write an equation or inequality that model the situation, then solve it. So the thing that I don't know is the previous balance. So that's going to be my variable. I'm going to call it x. So if that's my previous balance, that means I started with x amount in the account. I withdrew $32. So since I withdrew $32, that means I subtracted $32 from the amount. And after I did that, I was left with $289.14 in the account. So this is the equation that we're looking for. This is the first thing that it asked for. So this is part of my answer. And now I have to solve this. So this was the equation. And now I need to solve that equation. And in order to solve that equation, I just have to add the 32 to each side. So when I do that, I do plus 32 on each side. So I'm left with x equals, looks like this is going to be a 321.14. So $321.14 was the original balance. Okay? The next one says, after you pump 8 gallons of gas into an empty tank, the gas gauge reads 2/3 full. What is the capacity of the tank? And there's really two ways to approach this. If we're writing an equation, one way we could look at it is in terms of a proportion. 2/3 of the way full, that's 2 out of 3 parts. Well, 8 gallons, there's 8 gallons in the original tank, and that's 2/3 of it. What was the original? So that's the total. So this is what it would look like as a proportion. If we wanted to write it as a true equation, we would say this. We would say, let's see, the full tank, the tank capacity, again, we're still calling x. So if I do x and I multiply it by the 2/3, that should give me the 8 gallons that are left in the tank. So these are the two approaches. Really, each of these technically is an equation. The proportion is maybe a little easier to think about. With the proportion, then I cross multiply. So that's going to give me a 24. Equals a 2x. And now I just have to divide each side by 2. So when I do that, I find out that x equals 12. So 12 gallons. For this other equation, let me slide it over a little bit. 2/3 of the full capacity is 8 gallons. In order to solve this one, I would multiply each side by the reciprocal. And when I do that, over here, the 3's and the 2's cancel, which is why we multiply by the reciprocal. So I find out that x equals. With this guy, if you need to take it off to the side and do some work, it's 8/1 times 3/2. Remember, we can cross reduce. 8/2 reduces to a 4/1. And now I multiply straight across, gives me a 12/1, which is just 12. Okay, so either equation works, and you get the same solution either way. So x equals 12, and I would probably accept the proportion as an equation. I would also accept the 2/3 x equals 8, more of a linear format. Okay? This one, it says the perimeter of the rectangle and the regular hexagon below are equal, and we want to find x. Okay, so we're trying to find x. So when we're talking about the perimeter, and since it's a regular hexagon, I'm going to start with the hexagon because that's a little more confusing. But a regular hexagon, that means that all the sides are equal. So that means every single one of these sides is 2. Okay? And now let's figure this out. We're talking about the perimeter versus, the perimeter for the rectangle and the hexagon. For the rectangle, remember, opposite sides are equal. So the perimeter of this rectangle, if I add all the sides together, I have 2 x's, so it's a 2x, plus the 2.5 and the 2.5 add up to a 5. So that's the perimeter of my rectangle. And then the perimeter of the hexagon, I just have to add all these together. There's 6 of these 2's, so that's going to be a 12. Okay, I just add them all up, gives me a 12. Now I have a very simple equation to solve. I found the perimeter of each, and now I just have to subtract the 5 from each side. So I end up with 2x equals a 7. And now I divide each side by 2. So I find out that x equals a 7/2, which I would accept it as an improper fraction. However, if we look at our problem, the 2.5, it's written as a decimal. So I would probably convert this to a decimal and call it a 3.5. Okay?